How does eye color really work, and why do our eyes look so different? Brown eyes are brown because they contain a high concentration of melanin, the pigment responsible for coloring your skin, your hair, and yes, your eyes. In the iris, melanin acts like a shield. It absorbs light rather than scattering it. So, while blue or green eyes reflect light in a way that creates a visible hue, brown eyes pull light inward. This is why brown eyes seem deeper, darker, and more grounded. From an evolutionary perspective, brown was humanity's starting point. The earliest humans had brown eyes because they evolved near the equator under harsh, bright sunlight. Melanin wasn't just pigment, it was protection. Brown eyes were nature's built-in sunglasses, filtering out UV rays and reducing glare, long before Ray-Bans existed. That's why even today, over 70% of the global population has brown eyes. It's not just a color, it's a legacy. Culturally, brown eyes have been linked to warmth, reliability, and stability, but they've also been described as mysterious, serious, even intimidating. Why? Because brown eyes are hard to read. They don't change with the light. They don't flash with emotion the way lighter eyes sometimes do. They absorb rather than reveal. But under certain lighting, low sun, candlelight, late afternoon haze, something strange happens. Brown eyes start to glow. Not bright blue, not green, but amber, honey, liquid gold. It's the melanin again, scattering light just enough to reveal what's been hiding underneath. Like an old texture map with a secret layer, only visible in specific conditions. In those moments, they feel ancient, like they're not just seeing you, they're remembering you. Blue eyes aren't actually blue, not in the way you think. There's no blue pigment inside the iris. What you're seeing is light scattering through layers of tissue, a phenomenon called Rayleigh scattering. Yes, the same reason the sky looks blue and sunsets bleed orange. The iris, the colored part of the eye, is made up of fibrous layers. These layers contain almost no melanin. Melanin is the pigment that makes eyes brown, black, or hazel. When light enters the eye, shorter blue wavelengths scatter in all directions. Longer wavelengths, like red and yellow, pass through or get absorbed. This scattered blue light bounces back through your pupil and out into the world, tricking everyone, including you, into believing your eyes are actually blue. But they're not. They're transparent. What you're seeing is the color of light's confusion. Every blue-eyed person on Earth, roughly 8% of the population, traces their eye color back to a single genetic mutation that occurred 6,000 to 10,000 years ago, somewhere near the Black Sea. In one human, a tiny change occurred in a gene called OCA2, a gene responsible for melanin production. But instead of breaking the code completely, it just dimmed the switch. It limited how much melanin was produced in the iris, and suddenly the eye didn't absorb light anymore. It scattered it. That one mutation spread from person to person, generation to generation, until millions now carry the glitch. Once you see them, they never leave your memory. Only about 2% of the world's population has green eyes. That's rarer than red hair, rarer than being born with 12 fingers. Why? Because green eyes are a chemical contradiction. They exist on the edge of a pigment glitch, a perfect storm between biology and light. To get green eyes, the body has to balance just the right amount of two things: melanin, the brown-black pigment responsible for dark eyes and skin; lipochrome, a yellowish pigment found in the iris. Most people have too much melanin. Their eyes come out brown. Some have almost none, so light scatters and their eyes appear blue. But green eyes, they need just enough melanin to darken the iris and just enough lipochrome to tint the light that bounces off it. Then comes the final ingredient, scattering, the same thing that makes the sky blue. Light enters the eye, hits the iris structure, and reflects back. But now it's been bent. The result? Green. A rendered illusion so delicate that the smallest tweak in pigment breaks the effect entirely. Green eyes don't sit still. They shift in different lights: gold, jade, moss, steel. They look calm in the shade, then snap with energy in sunlight, like they've got a secret loaded behind the iris, waiting to be triggered. Green eyes aren't just rare, they're unstable beauty. An optical accident that stayed. Hazel. Yesterday, your eyes were green. Today, they shimmer gold. Stand near the window, they go earthy brown. Step into a blue room, they lean toward olive. You're not imagining it. Hazel eyes don't pick a side. Think of hazel eyes as a living texture. They aren't defined by a single pigment, but by a blend of melanin layers and optical trickery. Here's the breakdown. Less melanin in the front iris layer equals green or gold. More melanin equals brown. Hazel sits right in the middle, and that balance is easily tipped. The result, an eye color that mutates with every variable: lighting, emotion, clothing color, even the direction of the sun. Hazel eyes are the only eye color with no fixed allegiance. They serve as environmental camouflage. Put them in a forest, they go mossy, leafy, wild. Beside a fire, they burn gold, copper, flame. Rainy weather, brown, stormy, soft. Emotion affects them too. Pupil dilation, blood flow, even microshifts in iris tension. Eyes respond like biosensitive hardware. Excitement expands the pupils. The green bleeds outward. Calm or tired, warmth takes over, soft browns and golds. Anger, something darker flickers through vicinity. They exist mostly in people of European descent, but have been found in rare, isolated clusters around the world. Some researchers argue hazel is just undercategorized green or light brown, but anyone with hazel eyes knows they're not less of either, they're both. Amber eyes. Humans aren't the only ones who wear this color. You see amber in wolves, owls, tigers, predators that don't need to bare their teeth. Their eyes do the warning. Amber isn't about dominance, it's about control. A quiet kind of power that doesn't announce itself. It just waits. Amber eyes are rare, less than 5% of the global population. They're often confused with hazel or light brown. But once you've seen true amber, you'll never mistake it again. They don't shift like hazel, they don't glitter like gold. They sit in the socket like a controlled burn. It comes down to lipochrome, the same pigment that causes red hair and freckles. When concentrated in the iris, especially with little to no melanin, you get something that looks unnatural, even when it's 100% real. Golden, coppery, even orange in some light. The color is so dominant it tricks the brain into assuming confidence, or maybe something deeper. Because amber eyes don't break eye contact. They don't dart or flick nervously. They look the way wolves look, when they've already decided what they'll do. Even if they're the kindest person you'll ever meet, their eyes feel like they came with a survival backstory. Gray eyes. Gray eyes aren't just blue eyes that forgot how to be cheerful. They are structurally and behaviorally different. A rare iris build found in less than 3% of the population. Biologically, they contain even less melanin than blue eyes. Less pigment means less absorption, which means more light bouncing and scattering across the iris. The result is glow, not in sunlight, but in shadow. Gray eyes are mythic. They appear in ancient stories. Storm gods, ice queens, forgotten monarchs, not because they're cruel, but because they're indifferent to drama. They see everything from a distance. Emotion isn't absent, it's hidden under layers. They don't sparkle, they simmer. People with gray eyes don't give away their thoughts easily. They sit in silence, not awkward, not passive, just observant. Scientifically, black eyes don't exist. What we call black eyes are actually very dark brown irises, saturated with melanin. The more melanin in the iris, the less light it reflects. The result is an eye that absorbs not just light, but attention, emotion, curiosity. In folklore, black eyes appear where the normal rules don't apply. Demons, shapeshifters, paranormal children, shadow gods, void entities. They're always associated with the unknown, and sometimes the unknowable. You look in the mirror, and your eyes don't match. One is blue, one is brown. This is heterochromia. Normally, melanin distributes evenly between both irises. Think of it like applying the same color filter to both eyes. But with heterochromia, the code falls out of sync. There are three kinds. Complete. One eye is entirely different from the other. Partial. One eye has a slice of another color, like corrupted data bleeding through. Central. The center near the pupil is one shade and the outer ring is another, like the eye is trying to merge two designs. Heterochromia doesn't just look cool, it feels like a story. Two eyes, two realities, one face. You didn't choose it, but something did. Somewhere in your DNA, a line of code said, let's give this one both perspectives. And the rest of your body had no choice but to render accordingly.